In this presentation, we're going to look at what thinking like an economist means. Thinking like an economist involves developing theories or models to try and explain the complexity of the world around us. These models eventually need to be analyzed and evaluated, and so that's also part of thinking like an economist, the way we go about doing that analysis. Then economists also need to test whether the theories they develop have some applicability to the real world. And finally, the whole purpose of this is so that the theories and the tests can be used to formulate policies to improve the situation that the theory has analyzed. Okay, that's often, as a teacher of economics, I've often been approached by students and asked, can you give me some advice how I can score well in the examination? And that prompts me as an economist to ask, well, what explains high exam scores? And obviously there are lots of possible explanations that I could proffer, such as you get higher scores if you study longer. And of course, if you're quite bright and communicate well, that may also impact on your score. If you have good teaching, then that will also help. Of course, some students will gain higher scores by getting hold of the exam paper in some way, or just simply from good luck by happening to study the appropriate questions that happen to appear in the exam. Now, the way the economists will attack this problem and say, well, what do I think is the main kind of factor that's going to improve a student's score? Well, the most obvious one is, of course, the amount of hours of study the student undertakes. So the formal way of representing the theory is to say, ceteris paribus, examination marks are positively related to the number of hours of study a week. Now, what does ceteris paribus mean? Well, it just simply means all the factors that could influence the examination score other than the number of hours of study are kept constant. So all those things like intelligence and good luck and cheating, etc., those are assumed to be constant. So if we kind of ignore those for the moment and assume them constant, then there's a positive relationship between exam marks and the number of hours of study a week. Now, economists use graphs to explain theories because graphs are very useful in homing in on the most important factors in the theory, and often by doing that they expose new elements to the theory which they hadn't thought of initially. Now remember, we're outlining a theory here. At this stage we haven't gone out into the real world to see whether this theory actually applies to the real world. We do that at a later stage. Let's put our theory on a graph. Graphs normally are drawn in such a way that the independent variables shown on the horizontal axis, in this case, number of hours of study a week, 2, 4, 6, 8, etc., and the dependent variable, which in our case is the final exam, is put on the vertical axis. So what we're saying is that the final exam mark is dependent upon how many hours of study are undertaken in a week. So if you choose independently, so to speak, the number of hours, this has an implication for the number of the final mark on the exam. Now, the theory is normally represented by some sort of line. And we've put a red line on this graph, which is reinforcing this idea that there's a positive relationship because the line has a positive slope. So more hours spent studying imply higher marks. But you'll notice as well that the line cuts, the red line cuts the vertical axis at 20. I could have cut it anywhere, but just for illustration purposes, we've got it cutting at 20. And so what this is saying is that if students spend 0 hours studying, then they can expect to earn some minimum mark like 20%. And that's accounted for by their natural intelligence, by all those ceteris paribus conditions that we held constant. So, in other words, that 20% has to be added to any extra marks that are gained simply from studying. So, reading off the graph, it's saying if students undertake 6 hours of study, they can gain 60%. A further 6 hours will gain them 100%. Now, this, of course, because the line is a straight line, it implies a constant gain, the same constant gain in exam marks for each additional hour of study. How do I know this? Well, just looking at the graph, you can see that 6 hours of study give rise to an extra 40%. Divide 40 by 6 and you get 6.67% extra. And that's the slope of the line, that distance over that distance. And then if you have another 6 hours of study, you get exactly the same score, extra score, 40%. So that's, again, another 6.67% for every hour of study. Now, it's quite clear that doesn't seem to be very realistic. So we must move to the next stage of the theories to develop it and make it more realistic.